I'm gonna grind these cation exchange resin pellets for the first step of preparing the membrane. And we're more or less following the recipe that's provided, that he open sourced. The only change is we're gonna use fiberglass sheet rather than ground up fiberglass in the later steps. Close this guy up. Okay, and this is the exact grinder that he recommends to use, so that's what we'll use. It seems like it gets pretty damn loud though. Okay, that was about 3 minutes of grinding. It definitely does get warm, as he mentions. I could see why it's limited to 5-minute usages at a time. This is very hot. So let's see if we can just take a peek inside. Ooh, now look at all that water vapor. Oh yeah, that did a great job. It turns it right to powder. Holy cow. Okay. Wow. I didn't think it would be that easy. Okay. So I'm gonna try and empty this out a little bit from the lid, because it looks like it cakes onto the lid pretty well. Yeah. Wow. That's fantastic. Stuff grinds really well. Well, I guess he did mention that he tried quite a few different grinders and whatnot before coming to this one, but this really did do a good job. I'll be curious. I'm going to take some before and after microscope images to see the comparison in particle size. Hopefully mine can zoom in enough for me to actually see distinct particles on this powder. But yeah, I mean, this is a huge difference for sure. I could see how this would disperse very nicely in the mix. So I'm just gonna get this off the lid as good as I can, and then close it up and just leave it to cool down. Because with how warm it is, I bet it's driving off a ton of water as water vapor, and we don't want them to dry out. Even though it's apparently not the end of the world if they do dry out, but it makes life easier if you don't let them dry out, because then you don't have to rehydrate the membrane or the resin powder. As a just quick little safety note on this thing, if anyone's gonna try doing this, make sure it says to, disconnect this before opening it, and that's because there's no safety interlocks. So this thing, if you open it up and you have it plugged in and you bump this, it will turn on and start, spinning that blade. So just be really mindful of that. And when you first turn this thing on, it has a good kick to it, because it's actually pretty powerful. I think it's like a 750 watt motor or something. But anyway, it will kick when it first turns on, even empty. And so just hold on to it, because if you have it on a table or something like this, it could conceivably fall off. And then if you have something in there when you first start it up, it will really kind of have a good amount of vibration to it. So just make sure that you hold on to it, and then after, I don't know, 10-20 seconds, it will kind of even out, and then you don't have to hold it. But I would say don't walk away from it when you're running it. And it only has, a runtime limit of 5 minutes before you have to let it cool down for 10 anyway, so it's not like you have to stand here for an hour watching it. Here's the fiberglass sheet that I got for this, and I'm basically replicating the recipe that he, when he did the podcast with, I think, what's his name? It's like Nighthawk Light or something like that, or something like that. Anyways, Nighthawk used a fiberglass sheet instead of the chopped up bits of fiberglass and like the strands, and that seemed a lot more convenient for me personally. So I'm just going to do the same thing. Basically, I'll just cut a square of this. Wow, the way that they have this folded up, it's not super convenient. Just want to get access to an edge here. Here we go. So, I'm just going to cut a nice sized piece that I can work off of. Yeah, this is supposed to form kind of the structural backbone and support of the membrane, keep it from disintegrating, breaking, stuff like that. This works. It's kind of amazing how easy of a, relatively easy of a process this is, all things considered. I personally don't have too much or any really experience with these ion exchange membranes. Just education and work-wise, never really came across them. This is the plastic sheeting that I'm going to use to cure the membrane on, because we're going to add some PVC cement to this, and basically we're just gonna, the idea is to mix some PVC cement with the powdered resin beads. He uses half by half, 50-50 by volume recipe beads to cement, so that's what we're going to use to, it's not all he uses, but that's what is like a good starting point, I guess. And we'll just paint that on here and then let it cure. I'm going to cut this actually into 4 pieces because we really don't need such a big piece to start with. And yeah, we'll let it cure for a couple of hours without letting it totally dry out. Again, keeping the membrane moist helps apparently. And once it's cured, we can further cut up the membrane to actually be able to get it to fit like for little test cells, and we'll see if it actually works as advertised by running a little experiment. Basically, it's watch pH changes, and we'll also have a control without the membrane and see those pHs. So be kind of proof of concept. See if he is right about how simple this is to make. Okay, so we're gonna mix it up in one of these solo cups. I'm purposely not weighing anything to demonstrate, because if this works, how easy it is to make this membrane. So we're just gonna, estimate 50-50 volume. We'll again I'm trying to keep this as sort of, you know, garage friendly as possible. No balances, no scales, just more or less eyeing things to be about half and half by volume. So let me just bring this powder over here. Okay, so we've got the powder weighed out. You can see that. Now I'm gonna pour in this PVC cement. Okay, so now we just mix it up really well. Get all the powder nice and dispersed. I think this is probably one of the more important parts of the recipe, is to really get that powder dispersed, because if it's not, you'll probably create dead zones in the membrane, and the cation, it'll basically be a lot less efficient in cation transfer, because the cations, the positive charges, won't be able to hop between those the negative charged functional groups that are attached to the resin bead that then get dispersed through the membrane by doing this little crushing to powder and then suspending them in this PVC cement. And he does mention that there's a paper talking about how this is possible in terms of the positive ion hopping between these groups to get to the other side of the membrane. So it doesn't require sort of micro pores for it to diffuse through. It just charge hops. But I'm guessing that there is a limit to that in terms of how far it can hop from negative charge group to negative charge groups. And so if they're too far away, they will very likely just not be able to the membrane won't be able to transfer. And I am noticing that I think this PVC cement might be reacting with this cup. Oh, yep, that it definitely is. Holy cow. Alright, well, that's that's good to know. So don't use these red Solo cups to do this, because apparently they react. So I'm just gonna do this. So this is already a really kind of bad experiment, because who knows, well, I'm sure it's actually relatively simple, but I don't know it off the top of my head, the chemistry that's happening between this cup and the PVC cement. I don't know what this is made out of, but it would probably be easy enough to look up. Yeah, it's giving it that reddish tint because it's just dissolving this cup. Well, hopefully this still works. If not, it's kind of a bummer, but with how easy this is, that's alright. Not too big of a time investment, and then I'll just redo it in a better container. I guess I'll use some glass or something. I just don't want to use any containers that would then... Wow, okay. I need to open the garage. Holy cow. Well, here's going to be try number 2, using an appropriate material for the mixing medium, because the first membrane, it looks okay, but if you kind of hold it up to the light, there's small little holes where the light shines through. So I think what happened was the PVC cement mixture kind of thickened up with the material that got dissolved from the solo cup. I think it's just polystyrene or something like that. So the material got basically dissolved, it thickened it up, made it a little goopier than it should have been, which then didn't allow it to fully penetrate the fiberglass weave. So this is, you know, if there's any macro holes through the membrane, it's not going to do its job properly in the first place. So trying again, got some of these paint mixer cups. These are HDPE, which should stand up just fine. I'm going to make 100 milliliters of total solution, so 50 milliliters of the powder plus 50 milliliters of the PVC cement, and go ahead and mix those up and try again. I'm just giving it a really good mix here, making sure that the powder gets nice and dispersed before I paint it on. And I'm actually going to take this outside and do the painting on there, because this stuff really puts out a lot of fumes, which makes sense because this is basically just a solvent for partially dissolving, you know, PVC connections, and it sort of creates a plastic weld in the spot where you apply this. So it's just really volatile, kind of fumey stuff, which makes it pretty unpleasant to work with indoors. So I'm gonna cap this guy off. So here's kind of the completed test cell. It's pretty much exactly how Robert did it on his demonstration, and we'll see how it goes. This time I have a correct membrane recipe. Oh, whoops, I just dipped my finger in that hot glue. So, and we're also going to be using these graphite electrodes just like he did. That's kind of the test setup. I was trying to see if I could pick up chlorine on the mass spec, which I couldn't, because I think the chlorine is basically too reactive, so it reacts before it gets to the detector, and then I don't see it on my mass spec. But I did see the hydrogen, at least on the cathode side. So that was when I was messing around with this other first cell that I made with the membrane that I kind of messed up because I tried to use a solo cup, which dissolved. But it still worked, which is kind of amazing. It just shows how robust the recipe is. So we're gonna mix up some water here. So here's some distilled water. And now we're going to add some table salt, sodium chloride, NaCl. So regular salt. All right, it's pretty much fully dissolved. Okay, this still needs to cool down a bit. I'm going to put some in to this as kind of a control where it just has the hot glue in it, but no, you say no membrane, and we'll see how that behaves. Okay, so here's that control made. We'll go ahead and see what the pH is. Should be right around 7. Probably slightly acidic if I had my guess. Okay, so, oh, it's kind of hard to tell with these, but somewhere around 7, 6.5 to 7.5, probably. Okay, now we're going to go ahead and electrolyze this water to show what happens to the pH during electrolysis. Okay, this is drawing. I have a current limited to 0.2 amps, just like Robert did in his demonstration that I rewatched recently. And yeah, it's bubbling away. Hydrogen and chlorine are being evolved. So we'll let that run for a good minute or so. And while that's running, we'll go ahead and add some of this water to only one side of the membrane to show that the membrane is impermeable. There's no impermeable to the just bulk water. No microstructure, no pores or anything like that letting flow through. So I'm gonna just let it sit here while the control continues to electrolyze. And we're coming up on about a minute here. Yeah, I can already smell the chlorine coming off. Pretty distinct smell. Okay. Well, let's see. So the pH is now probably more, yeah, it's gone more alkaline overall in the cell. Which makes sense because we're driving chlorine off, sodium ions are still left behind, hydrogen is being driven off on the cathode, which then liberates a hydroxide group, I think. And the hydroxide, along with the potassium, slowly make the solution pH go up, making it more alkaline. Okay, that was relatively quick, you know, a bit less than a minute to do that. So now we will go ahead and remove the electrodes from the control cell. I'm gonna give them a quick wipe down here. And this is just meant to be as a very kind of crude demonstration of the membrane actually doing its thing. This is by no means a rigorous test or experiment. Okay, so here's the cell with the membrane. Still got the water on one side, nothing on the other. I'll go ahead and add water to the other side now. So here's the membrane cell. Go ahead and take the pHs of both sides just to show that they're both starting off equal and more or less neutral. Yeah, again, fairly hovering around that 7.0, give or take. pH strips aren't the most accurate things in the world, but it's good enough for this. Okay, so now we'll start the electrolysis. Okay, we'll let this run for about a minute. So now it's taking about 14.5, a little less volts to drive the 0.2 amps. It's quickly dropping. That's apparently due to the polarization of the membrane, and the resistance across it drops. As you run the electrolysis, sort of, I think you can think of it as almost conditioning the membrane. I'm sure Robert would be able to talk more about this. Okay, so almost been running for about a minute now. So we'll take the pH first of the cathode side, and what we expect here is for it to be pretty basic. Okay, so we're pretty much maxed out on the range of this. These go from 2.0 up to 9.0. So this is pretty much indicating a 9.0 pH on the cathode side, and on the anode side, let's see. On the anode side, definitely not basic. Looks like we are trending down, getting more acidic. So there you go. I mean, it works. It definitely works. That's kind of amazing how easy it is to do. All credit to Robert Karasak, or however you say your name, I'm not sure, from the RoWow YouTube channel. He's the one that patented this recipe for the membrane and then went ahead and open sourced it. But this is definitely impressive, and especially considering that I messed this up in the first place when I made this first one, because I put it in a material that the PVC cement dissolved right away, which then made it all goopy, and it still worked. So yeah, this is pretty cool. I think probably worthwhile pursuing some projects with this. Maybe I'll see if I can adapt this to my neodymium magnets project. I've been dissolving some magnets and seeing if I could recover the neodymium out of it. Apparently you can use this also to plate out pure iron. I'm not an electrochemistry guy. I have little to no experience with these membranes, but supposedly they can be applied to give you a sort of chemical reaction control advantage across a lot of different reactions that normally you don't get that advantage with, and one of those things is purifying iron. And since my neodymium magnet solutions are like 60 to 70% iron, that might be a good experiment to do too, is to see if I can plate out more or less pure iron from those solutions.